traffic these days sucks. Hey, my name is Shandeep Singh, and let's talk about how we can fix it. Approximately 3.3 million cars are registered in the Bay Area. An average of 83 hours per person are wasted while remaining idle due to traffic jams. Many factors cause traffic jams, however, one factor is traffic lights. Current traffic light systems are based on timers. Such systems are not precise and cannot adjust to changes in traffic flow, leading to traffic jams. Major cities implement timer-based systems in downtown areas. So if you miss one light, you have to stop at every traffic light. Another issue is that current camera lights are only used for catching violators, but do not offer any analytics such as how many cars at an intersection. And lastly, cities install electromagnetic systems that only determine the presence of a car, but not how many cars. So what can we do to improve this system?
So I propose solution using a video analytics software capable of detecting objects and known as YOLO. YOLO is a real-time object detection system that uses machine learning algorithms to recognize and label objects such as vehicles. By using YOLO in conjunction with Amazon IoT services, we are able to create a real-time and smart traffic controller that is capable of providing traffic analytics such as number of vehicles at an intersection. Now let's dive deeper into the system design and see an overview of how the system is interconnected.
I'm CY Wong. I'm working on this project. I've mainly focused on the IoT connection, the hardware side, and the database management. Okay, so this is the brief box diagram of our project. So I will briefly explain how the whole process will go. First, we use a local PC, and then with a graphic card, and then using the YOLO object recognition software to process the image, and then the software is slightly modified, and then it will return the number of cars per of each image, and then we will simply use it, run it every 10 seconds, so we can get an estimated traffic flow per 10 seconds. And then we use the MQTT and connection and upload the data in JSON format to the IoT, AWS IoT, and then the AWS IoT will trigger the rules and then push the data into the DynamoDB. Also, the DynamoDB will set up another trigger to trigger the couple lambda function, and then by reading the lambda function, by reading the data from the database, it will decide which traffic light should goes to green or which traffic light should goes to red, and then send back the stop or go signal to the traffic light using the MQTT again. Okay, so we can start the demo of the IoT device right now. I will show you how the YOLO will upload the data to the AWS IoT. And then first of all, we have a data file that saves tons of photos that of many from the web, and then it's like fake data for us to test. Okay, and then we start running our program, and then currently it's loading the weight and then start to process the data. And I have set up the subscriber to the topic on the AWS IoT, so if there's any message coming, and then you will see here. So the current time is 6:45, and then we've just got the a new message coming from the IoT device. And then we can go to the DynamoDB to see, because we already set the rules, and then any new message will push directly to this database. Okay, so I think 6:45 is this too. Sorry, I forgot to query the data, so it will be a little bit messy, but here is it. And then we also have a trigger to trigger the different Lambda function, and then we also create a second global index so we can do the sorting much effectively for our Lambda function. Okay, we first of all we create a structure of data structure like in JSON format, and then this will be the message that push to the IoT, AWS IoT, and then these are all using the AWS APIs to make the AWS connection. For example, here AWS IoT clients, and then configuration, the endpoint, set the endpoint, and then put all the certificates, private key, and to them. And this is our main function. So first of all, we just connect to the AWS, and then run the YOLO function, detect, and it returns the how many cars in that picture, and then we can push it to the IoT using the publish function.
My name is Casey Reyes. I'm a software engineer major, and I'll be going over one of our Lambda functions. So Jay talked about MQTT and how it publishes to our AWS logs. Using DynamoDB, we created tables that update according to our Lambda functions. We will check out our traffic table. As we can see, under our traffic table, there are different locations with a flow count. The flow count is the number of cars that are waiting at a specific stoplight. Now we will check out one of our Lambda functions that uses this database. Traffic control will send and receive signals from AWS to our Raspberry Pi. The signals are the on and off signal. The way the on signal is triggered is when a request is sent, the location parameter and flow parameters are passed to verify that the stoplight has a long queue of cars to set the stoplight from green to red or from red to green. The off signal is triggered when the stoplight switches from green to red when opposite stoplights from the same location is triggered.
Okay, right after the data from the database has been processed, one of the Lambda function will make a decision to invoke another two Lambda functions. One is to turn on the signal. It's like turn the traffic light from red to green, and then the other one is turn green back to the red. So these two functions will be invoked once the data has been processed, and then based on the logic to make a decision whether the traffic light should be turned to red or turned to green. And this is the demonstration of how these two Lambda function is going to send MQTT message back to the traffic light. So first of all, we just trying to turn off the signal, and then we click test. On this side, yes, and then we will receive off message from the traffic light, and then if we turn it back on, okay, so we will receive the on signal here. In this video, we will demonstrate how the Lambda function will send a turn off signal from the cloud back to the IoT device. First of all, we just hit to invoke this function, and then from the left side we can see the MQTT clients that the off signal is sent to the IoT device already, and then here is the turn it to red, the LED light, and then we can try another one which is turn the Lambda signal on. Okay, once I click hit, okay, and then the IoT device right now turns back to the green light.
So in conclusion, you saw a tested simulated version of our real traffic light controller with the Raspberry Pi. We used the AWS IoT platform and the YOLO framework to create this whole system.